Hello. There you go. Okay, good afternoon, everyone, and welcome back. We're just about to resume for session number two for the DNSSEC tutorial. As explained previously, we have the wiki page, which has information about presentations and the exercises. And we have asked you at the end of the session as well, if you are interested to follow along with the labs, please add your name next to this table so that the server will be reserved for you. For those in the room that don't have link, please just approach us and we can add this. The link is also posted into the Zoom chat box, so you can also use that link if you are keen to, follow along with the demo and the lab. Yep. Anyone in the room want to join and do the labs? Show a raise of hands perhaps so that we can add you to the list. So Awal is going around adding people's names. For those that are online, again, the link is already posted into the chat box. So please add your name next to it. The agenda page to the wiki will also be posted in there. Maybe we will ask Awal to do that for us because I'm not in the room at the moment. And once you have done that, perhaps open up the topology. This is the topology for the lab that we are doing. Just maximize that quickly for you. So it's a very simple topology where we have 30 VMs, and then we have kind of like our own DNS ecosystem in this lab. We are maintaining our own root. It's one the root server, which is 192.168.30.51, and our own TLD server, which is 192.168.30.50. Both of these servers are reachable from the assigned VMs. So let's say if you are logged into server 1, you should be able to reach the TLD and the root and actually use them to do the DNS query. So what we can do now, while you are selecting your servers, is just very quickly, I'll go through here and show you how I did it. Maybe I'll get out of here just quickly and using one hand. Okay. So, sorry, so SSH into the server. So in that case, it's 202.125.97.43. This one, okay. Go to 125.97.43. Log in with the password, and then now you are in the jump host. You can then SSH into the server 30.1. I think for myself, you can also use APNIC add because it's a username, but we're already user APNIC, so that is not really necessary. And then add in the password, and you should now be on the group server. So again, 2 levels. SSH into the jump host first, and then SSH into your assigned server. And if you're already here, have a look at the, sorry, let me just go back quickly into this. At this point, there is nothing installed on those servers. So we will be doing everything from bind installation to enabling forward DNS, adding domains, and signing them. So if everyone is ready, let me just quickly go into this. So far, we have a few people. Again, this raising point. So if you can. All right. These are the login details as I've shown you in the other in my terminal. Just showing this here so we can check if everyone can log in. So we have 1, 2, 3, 4, 5, 6, 7 folks, including myself, I think, there. So if you are having trouble logging in, please let us know. Otherwise, this should be simple and straightforward, hey? Good? Yes. Just make sure to follow the IP address correctly for your assigned server. So what I'm going to do now is just quickly open the lab. I think this is the first one, the installation. Put it in here so that it's easy for us to follow the instructions together. Like so. And what we're doing here is install Bind. Bind is only one of the DNS applications. There are others. You have Bound, not DNS, you have Power DNS, Microsoft DNS, and a few others. But in this instance, we are using Bind, which is one of the most popular DNS application or software that is free and open source available out there. And it's also maintained, actively maintained by a ISC who manages and published this software. So going into this, we're now accessing the lab and going into B. We will be installing all the requirements. So this is just typical. You would do an update first. Then wait for that to finish, just making sure that all the required applications are up to date. So that should be quick. Get install -y. -y is just yes. So it won't prompt you anymore. It will just continue because you already confirmed it. So we're installing OpenSSL in this case, which is that one. So OpenSSL version, we now have this version installed. Hope you guys can see that. Maybe I'll make it a bit bigger. Okay, or you can also add a -a there to give you a lot more information about that. But yes, just make sure that the OpenSSL version is, the minimum required by the software or the application. Next, we will be installing all the other dependencies, bind9 included, bind9 utils, and DNS utils. All right, I'm typing too fast. There you go. You wait for that to finish. After that, there should be this folder, which namely is your name daemon. Namely -v. We have bind 9.11.3 package for Ubuntu installed. That's good. You also have a lot of the utilities required. Usually it's in this folder, or maybe it's in user bin or user bin. So let's try to see there. User bin for all the DNS related stuff. There you go. So it is in here. Quite a number of utilities and commands that you can use when generating keys and signing your zones, etc. All right. So with that, we should be good to go. DNS has been installed, and we're finished with the first part of the lab. Simple enough, right? Yes. The Word file, it's in the wiki, yes. So if you're here, you notice we have the exercises, the topology, the installation, and then the DNSSEC validation. Let me just download the second one. This will be the second exercise that we will be doing. Got it? Anyone else having issues online? All good? All right. So with that, I'm going to open this second file, which is for recursive DNS. So we will be configuring, I think I have to install the forward DNS. Or maybe not necessary. Okay, that's fine. It is recursive. Let's open that. Just 1 second. Usually just open on that page, but it didn't this time. So this, put that in here, just so again we can use that as reference. All right, so we are here following DNSSEC configuration on your recursive resolver. That's lab exercise number 6. So at this point, we have DNS already installed. As we've done in the first exercise, you have named in here. You can verify with named -b. We have a folder for all the config for bind, which is /etc/bind. So what we're going to do is go into that folder. Once you're there, you see a few files, configuration files already there. We have namely.conf.local, okay, namely.conf.options, this one here, and you also have the default zone. So, and then if you open the bigger file, which is namely.conf, it actually links to those smaller files. So in some cases, if you are an experienced DNS administrator, you would just put everything in one file, right? But these are defaults, so go follow the defaults and then add the config on the necessary subfolders. But if I just quickly go into namely.conf here, notice that it is pointing to those 3 files that I've previously opened: options, local, and default zones. We will be updating mostly the options and the local file. The default zones would normally have all the zones pre-configured, usually zones that are used for like private IPs, RC1912, as well as your local host and your heads file, which is on top. So all right, we will go into the options file now. I'm using VI as my text editor. You can use others, say Nano, others. I'm so used to VI, I just generally use that, but we should have other text editors in this server that you can also use. So let me open namely.conf options, just this one here. And we have this option statement, right? Whatever you put in the option statement would apply on all the zones. If you want only specific for a zone, usually you can add it under the zone statement. So in here, we will have options and then DNSSEC validation. Let's set it to yes. Okay. Right now, it's set to auto. As explained earlier, you have options to set it to either yes or to auto. In this case, let's use yes. Then after that, we can restart. Restart Find9. There are other ways to restart your service, but for now, let's keep into just restarting using the systemctl command. You can also do status just to see how it is, if there are any errors after you have restarted. What you're looking for is something like this that says it's active and running, and also that your zones have loaded. You can either see that here, or you can open another another terminal, I suppose, that shows all the logs. This is log, and then keep it running from there. So you see every time that you have to restart your service, you will see if there are any errors or not. So with that done, it is running. We can do namely minus G minus C. Actually, we're already doing systemctl, so let's just skip systemctl. You have this option as well, minus G if you want it to run in the foreground. Minus C is specifying the configuration file if it is in the same folder or any other folders, just to make sure that we have the full path to that. And then minus U is the user. Generally, that will be the bind user. So since we have systemctl, that's usually the easiest ways to go. Just making sure that your config is in the right folder where it picks up. And if it is in another folder, just make sure that you update the config file to point to those files or locations accordingly. So, yep, let's just restart bind mine again, just to be sure that we've done that part. And then systemctl status to see that it is running. What I'll do now is again SSH into the server. So we have a different here, SSH 192.168.3.1. Okay, then sudo tail minus f var log system. Yep. And yep, what you're looking for here, just to make sure that your zones are loaded, there are no errors. Okay, and you should be good. I'll go back into here. Okay, and to do a simple dig query. We've already seen these commands earlier. We've used dig in a few presentation, a few slides, right? Dig is a utility that's installed when you initially installed bind utils or DNS utils. And it's a very useful utility that comes with bind, of course, and you can use that to do something like this. So dig at your localhost 127.0.0.1 or at localhost, whichever you prefer, plus DNSSEC, because we are doing DNSSEC, of course, and then you specify a domain, and it will give you information about that. In this case, the commands given here is if we've already done the other parts, which is the DNSSEC zone signing. At this point, we haven't exactly done that yet. So what you can do once you have completed this part, this should have access to do queries over the internet. So you can query for any domain that you like, maybe apnic.net. Hopefully it will give us a good information. There you go. It does, but this is behind Cloudflare, so maybe let's use apnic.net or training.apnic.net or academy.apnic.net. Let's use this one. There you go. So after adding how many lines? You only updated actually one line, DNSSEC validation, and we set it to yes. And actually, even if you kept it to auto, it is essentially telling you that DNSSEC validation is already available. It's already enabled by default on your server. And most DNS software applications are configured that way. Having the DNSSEC validation line in your configuration file is still very useful. It allows you to see, what settings are there, yes or auto, or if you wish to then disable it at some point, maybe you're trying to troubleshoot something, right? And you want to disable DNSSEC validation, you can also do that by adding a no in the DNSSEC validation line here. We'll set this up first, and then we will continue. Thanks, Awal. I think Awal is holding it now. So glad we have this. All right. Thank you very much, guys, for setting this up. All right. So there we are. Once we did the query, again, dig plus DNSSEC at localhost or at 127.0.0.1 for a domain. In this case, I use Academy. We're able to get response, right? We have our A record, which is really what we want. Even if you have DNSSEC validation, it should still, perform as usual. It would still get the records that you requested for, but in addition to that, you now have a corresponding signature of that RR sig, so of that RR set. So this is your RR sig record, which I hope you already know how to, check what are different parts. It's a signature for technically three, so you may have one more line before this. So three A record, so this is A record, using type 13 DNSSEC algorithm. This is the TTL 300 with 5 minutes, and then this is when it will expire 0525, and then 0523 is when it's signed. So only 3 days validity. So I think it signs that every so often. And this is the corresponding signature of that RR set. Pretty much what we have in the slides. The good thing here also is for all the additional information you guys get, like you have a few new A records that it pulled, right? So they will again also have the corresponding signature for those DNS. As discussed earlier, you should see, well, there's no AD bit here, but there is a bit, which is DNSSEC, DNSSEC K, so it will do validation. DO bit, as discussed earlier, should show you that. Now, the reason I think that there is no AD bit is the records are probably coming from cached information. So it's not directly coming from the authoritative server, I believe, at this point. But yeah, we can try to verify that. But at this point, we now have a DNS server that is performing DNSSEC validation. Any questions? Is it easy? Oh, you cannot find that from the wiki, this one? This is DNSSEC validation. Yeah, Awal can also come and show you. Yes, sorry, yes. We're trying to complete some of the exercises that were in session 1 because we ran over time for that session. Sorry about that. Okay, how about the rest? Can everyone follow? Everyone who's doing the lab are able to follow? So, again, maybe just reiterating an important fact here, because DNSSEC validation really is, configuration-wise, quite simple, right? You just need to understand the DNSSEC validation line, what the options that are available are, and what they do. So you have no to disable DNSSEC validation, auto to enable that, using the global root as the default. You set it to yes if you're relying on a trust anchor, which we're actually going to do in this lab because we have our own little independent setup here. But generally, you would use auto. And like some trusted keys, which will come in handy later on, essentially for your. But essentially, those three options are quite important to understand. And aside from that, it's really just updating one line in the option statement on your bind config file. But the repercussion, obviously, as we have discussed, okay, if um, a if validation fails, okay, that site, that domain, that record will not be forwarded to the client, which means the site may not be reachable to your customer, to your client. So it's just some information that needs to be propagated, or make sure that your users are informed before you implement DNSSEC validation. Okay, and make sure that your team, your help desk, your support team are also aware of this. That it may be one of the reasons why a site is not reachable. So when you're troubleshooting, you can check, if site is reachable either because there's a problem with routing, or the site is down, or maybe it's because of DNSSEC validation. Just keep that part. Yes, if I open namd.conf, you mean? So namd.conf is the big file, but we have smaller files. This where we put config. So namd.conf options is I think that you want it. So under options, we have this DNSSEC validation set to yes. Just trying to troubleshoot here. If you are online and you have questions, help with troubleshooting, please let us know. At this point, we should have a running DNS server that is doing DNSSEC validation. So we'll just give it a few minutes until everyone has managed to do the configuration on the end. Assigned servers. Again, you can try to do the query and try any other domains. Here I've got apnic.co.th. Give me information, right? Same thing, we have a record, ask for corresponding or signature for that A record. Yeah, there's no 80-bit for some reason here. Trying to see why. Maybe because what if I just trying to look at options here? We set it to this auto so that it will use. But right now, check. I have the by default in the way, so it's pointing to the right root servers. Options again, going into here. Let's just try other options. Maybe DNSSEC validation set to auto. Chooses the root as the automatic trust anchor. start find9 sudo here. There you can see in the bottom that we started. I think there shouldn't be an issue. Trying to resolve, so you can ignore a lot like network unreachable there. Let's try to see the status. Okay, it's still active, it's running. Doesn't seem to have any issues except for that check hints part. Dig at post. Let's try picking it again. Post DNSSEC. That is the size of it. Maybe it has something to do with this. It is the problem. Yeah, it wasn't working. So maybe there was some reachability thing there. There is still this serve failure, but right now it is resolving. First one is the one's cache, but looking at this first one here, yep, we have the 80 bits. It's set to auto. So yes, if it's set to auto, because that is when it will use the root server as the default trust anchor, and you have the complete validation, the chain. If you remember the discussion about the chain of trust, it needs to be able to get that validation all the way to the top of the trust anchor, which is the root, for that to be authenticated. So that's when you have the 80 bit. Now for the lab, there is a reason we set that to yes, and that's pretty much for the lab purposes, because we have our own little setup, as I've mentioned. When you look at the topology here, we have our own little root and TLD server, which makes it a lot easier for us for the lab to add records and do the signing. That's why it is set to yes. So if you are going to use a third-party trust anchor, which, as I've said, when we used to do DLVs, I don't think there is a reason for us to do that now. Instead, aside from, of course, doing it in the lab. So setting it to auto is general acceptable thing to do. But for our lab purposes, we have set it to yes because we are setting a different root. All right, so that just to explain that part. But if you use auto, as you can see here, there is an 80 bit. And of course, the most important part is it is resolving, and we have a corresponding. Are there any questions? Give it a couple of minutes to digest that. You also do some queries yourselves. And once that is okay, we can proceed with the next part, which is DNSSEC zone signing. What I'm going to do at this point is maybe download that zone signing part. have to do both, right? So this forward DNS, also forward DNS with DNSSEC. That next. FYI, this is the next part, forward DNS and forward DNS with DNSSEC. And if we have time, we can also do the same for reverse DNS for and shall we do the everybody okay with that? All right, I'll make this as quick as possible. So I know you're more interested in doing labs. So we will try to make that quick. But just very quickly, I wanted to touch on the core concept, right? I think at this stage, with all the explanations we've done so far, we do understand that there are two parts, the DNSSEC validation, which we have just completed, including the labs. So the next part will be DNSSEC zone signing. This is still not working for me, so I'll just use this one pretty quickly. And I wanted to show you some statistics. So DNSSEC deployment, it's actually going pretty well. We have what, millions of DS records already added, which means those zones have already been signed, and this is as of this year. We can have a look at that from the web, from that side. And also, equally as important is checking whether the TLD has been signed, because we already said root is signed. Okay, I think it's around 20, was it 2010 or 2012, something around that time, that the root is signed. And then slowly followed by the biggest TLDs, .com, .net, etc. There are heaps of top-level domains though. You have CC-TLDs or country code top-level domains. You have generic top-level domains, right? You also have IDNs or internationalized domain names. So you have heaps of domains. So here we're just looking at CC-TLDs because I think it's also a good gauge of the economies. So far, the green ones are operational, meaning for those CC-TLDs, it is DNSSEC signed for the CC-TLD, which makes it easy for you if you have, let's say, a .th or a .au or a .sg subdomain. If the TLD is signed, makes it easier for you to also be able to sign your subdomains. So from here, as of yesterday, this graph or this map is actually provided by the Internet Society. Most of them, 78 to be exact, is operational. Some are experimental, some have it partial. But where is Thailand? I think Thailand there should be signed. And it is true. I've actually was verifying that yesterday morning when I was preparing this presentation. Do a simple dig query, right? Dig at locals. You already know how to do a dig query at this point. If you do a, yeah, exactly. We already did query about BKNX, which is this. Another thing you can add here, maybe from this command that we've done, is to use a plus trace. So, oops, sorry. I don't think it's showing in the in Zoom and in the presentation, but you can do this from the VMs. So dig at your localhost or your VM IP address, or in this case, bknix.co.th plus DNSSEC, and then just add at the end a plus trace, TRACE. So that will go through the different levels, starting from the root. And you will see Try to make this bigger. You will see that all of them are signed. Go back up. Yep. So I'm just trying to make sure that it shows in the screen here, but try it out yourselves. Dig at localhost for something that co.th or just.th, and then plus DNSSEC and plus trace. You should see that at each level, okay, dot is signed because we already said root is signed, .th is signed, co.th is signed, and dknix at co.th is signed with the corresponding signature added. Don't worry about it. I'm going back to the slides. But yeah, try it out yourselves. Now where's my presentation? There you go. um, next part, again, this one is specific for the AP region, our region. Okay, it's looking nice, but I think the sad part is you have quite a number there, either the grade ones or the uh, orange, which is experimental. So our goal is to have 100% of this already assigned if possible. So just going back quickly into the wiki, there should be a link there about the, I'm just looking for it. I think this one, the ICANN TLD report. If you can find the ICANN TLD report, is it open? Not sure if it's open. There you go. This one here. Okay, these are the TLDs that should have been signed. There are 3 columns here. If it's signed, and if the DS is in the root, or the DS is in a third-party DLV, such as the one maintained by ISC. And this has been decommissioned for many years now. So technically, you should not see anyone using a DLV, but it was for quite some time very useful again during the transition period when we don't have the root signed yet. But what you should see is the DS should be signed. Bigger for most of us in the room. Okay, so it looks good because most of the TLDs are signed, and that's what we are after. However, take note that some of these, this one is not signed, this one is not signed. Awal said don't show BD, which means I'm gonna show BD. Oopsie, there you go. Unfortunately, BD is not signed, and because I mentioned BD, I'm going to have to mention PH as well. So Philippines is this one, which is also not signed yet, along with the PG and the PF. But for us here, the TH is really good. It is signed, yes, yes, and it's all green. Good news, right? Everybody happy? Yeah, makes you proud. Awesome. So that's good. So I think no excuses for us to then start looking at signing our zones. I think majority of websites that you access locally are under .th. I know because some in some places they tend to use more of generic TLDs than the CCTLDs, but I believe for Thailand it's mostly .th, right? So yes, now you can sign your zones, but before fully implementing that, it's not as simple. There's quite a few things to take into consideration and to plan. It looks easy when I mention it, but of course, when you do it yourselves, again, proper planning is required. You need to be able to plan about your key rollover. We were just discussing this during the break. This is perhaps the major, I wouldn't say downfall, but the major hurdle for a lot of folks who are just starting out with DNSSEC signing, because the signing part is doable. The signing part is looks like a one-off thing, right? You schedule it, you sign your zones, but there is maintenance involved, as discussed earlier about the analogy with insurance, right? It is something that you will have to, do often. You'll have to re-sign your zones. You'll need to have to generate new keys. So you'll have to think about key rollovers. Another part to that is, of course, making sure that the keys that were generated are secure. Where are you going to store it? Is it going to be on the same server where it generated? Will it be on a DNS server that is behind, let's say, a firewall or a DMZ? Or will you be storing your keys in maybe a security module, an HSM, or something similar? And then what happens if your keys gets compromised? For those that have implemented DNSSEC maybe a little more than 5 years ago, perhaps, at that time, the considered, I'd say, best or like preferred algorithm may be RSA, a type 8. Now, if you are considering to then move into other algorithms, that's another planning to do. Okay, the switch to newer algorithms or maybe different key sizes, again, is something that you will need to also plan. So what I'm going to do now is to show you quickly some of the steps that is done when you do sign zones, and these steps are manual. When I was doing DNSSEC, trust me, it's all manual and it's all not very easy commands and support from the DNS applications. A lot of that has now abstracted and the software is doing it for you. Just need to really easily put your keys in a central folder and then it pulls all those keys and signs for you and even does automatic signing. But I find that it is still quite important to understand all of these steps, okay? Because you will be the administrators. If something goes wrong during like an automated process, you should know how to troubleshoot it. You should know where the problem is and what the whole process exactly is. And it's a bit like this. Obviously, this is quite specific to bind implementation. But other DNS applications should mostly be similar and follow the same steps. So the first one is, of course, to enable DNSSEC in your configuration file. Similar to how we've done with our DNSSEC validation, you just update your configuration file, your name.conf, your name.conf.options, etc., and add a line for DNSSEC enable. Okay. And then there are options to automate that if you use auto DNSSEC later on. But essentially at this stage is enabling DNSSEC following the commands or configuration syntax by the DNS application. The next part is generating your keys. We've talked about two sets of keys, right? ZSK and KSK, zone signing key and key signing key. Zone signing key used to sign your records, and then key signing key used to sign the zone signing key. So in this case, we're actually going to generate both of them. Generate your ZSK and generate your KSK. Again, this command is quite specific to bind. So the command that we use is DNSSEC keygen, and you specify the algorithm. Here we're using RSA SHA-256 because it's easier to see the difference between the two keys when you're using RSA. So that's the only reason for using still using this algorithm for this example. But you can see in the note there that generally the operational choice is to now use ECDSA with a key size of usually still between 1024 and 2048 bits, but mostly 2048 bits, I think, for KSK. So that's after doing the key generation, you should have 2 files each. Okay, one private key and one public key. Okay, for ZSK. And then when you repeat the process, of course, for KSK, you'll have another 2 files. So altogether, you have 4 files for both the private and public keys. This is just the complete command that you can use for ZSK and for KSK. And this one, again, is an example. Similarly, for reverse DNS. So the only difference there, I suppose, is the domain use, which is the FQDN for the reverse zone. So if you want to use NSEC3, because we've discussed earlier that there are advantages to using NSEC3 over NSEC, then a few minor changes in generating the key to enable NSEC3 here is to add a -3 as part of the command, and that should signify NSEC3. So once you've generated the keys, right? So these keys will be used for signing the zones, and you also need the public key to be published on DNS, so it's publicly available. So how do you publish the public key? You add it into your zone file. So a couple of ways to do that. You use the include directive. With include directive, you're pointing to a file that contains that information because you've already generated the public key, right? So you can keep that in that file and then just point to the location of that file using a $include directive. The other option is to manually add or include the contents of that into your zone file. And then lastly, which we are tending to use now, particularly for automatic signing, is to add that into a central folder, the keys directory, okay? And then from there, the software will pick it up during signing. So those are the different options for publishing the public key. And then now you're also going to use those keys to then sign the zone. So this is the zone signing part. And particularly for bind again, the command for that is DNSSEC sign zone. If you remember earlier when we looked at the different commands available after we installed bind under user-res bin, I believe, we saw a few commands and utilities there. One of them is DNSSEC keygen, another is DNSSEC sign zone. So DNSSEC sign zone will be for signing your zone and then easily just following that syntax. So -O, provide the zone name, -N, okay, and then increment. Increment is really just so whenever you do the signing, you don't have to manually update the serial. I hope that you know what the serial is for. It signifies that there have been changes into your zone file. And if it is higher than the values that are in the secondaries, it will pick up the new file. So whenever you sign the zone, or really whenever you make changes into your zone file, you will update the serial. Okay, increment the serial. So with the -N increment there, essentially just telling, deciding to also update or increment the serial together with the signing, so you don't have to do it manually. The next one is -F, the output file. In some cases, we don't generally use that. If you don't, it will just essentially use the previous file name and then add a .signed at the end of the file. So if you want something different, then you specify an output file name in there. And then -K is the KSK file, followed by the zone file, followed by the ZSK. So that's the manual way of signing. You have to specify the zones that needs to be signed. You need to specify the keys that will be used. So you specify both the KSK and the ZSK as part of this command. And then once it's signed now, again, if you don't specify a -f, a new file will be generated with a dot sign at the end. So that's how it's generally done. There is what we call now as like signing it in line or on the fly. So it doesn't generate a separate file with all the signatures added to it. What it does is sign the records in line. You know the location of the keys. When there is a query, that is when the records with the signature are generated using the keys. So it doesn't have to have this signed zone file generated first before you do queries. But that's how it's always done. And this is the manual way of doing it. Now, just a few notes when you're signing that there are records that are signed as part of the signing process. There are records that will not be signed. So if there are name server or NS records, if it's NS record for the zone, it is signed. If it's NS record for the delegation, remember we add like an NS record for the delegation and a glue for the child when we're doing delegation. So NS record for that child zone will not be included. Any DS records are signed, obviously, because you add the public key of the child to the parent, they sign it to signify that it is correct, that it is authorized, that this is the correct delegated child zone. And then if there are any glue records, because it's not really part of the records under the parent zone anymore, it's been delegated, so glue records will not be signed. So if you are doing this manually again, you will notice that there is a difference between the file size of the original zone file as opposed to the new generated zone file. Why is that? Because you now have a few extra records added into the new zone file. You have all the signatures that we talked about, the DNS key records, the NSEC or NSEC3 records, and that adds up. Typically, the file will be what, 4 times bigger at the very least, maybe more. And if you have like a minimal number of records in your zone file, it doesn't really, I guess, like it's not a big deal. But if you have thousands and thousands of records in your zone file, then it makes a big difference. So the new generated file will be much bigger, which can also mean that the transfers or the zone transfers of these records of these zone files from your primaries to the secondaries will also take time. So again, one other aspect that needs to be considered. Now, I've mentioned a little bit about inline signing. This is the commands when you do inline signing. You specify where the key repositories is using the keys directory, which generally you will add in the option statement in your configuration file. If you wish to add it specifically for one zone only or a number of zones, then you can also add it in the corresponding zone statement. And then you will then have these 2 lines under the zone statement: auto DNSSEC maintain and inline signing. When we go into the lab, we will show you this because we have both the root and the GTLD for the lab have been configured to use inline signing. So the configuration essentially will have these 3 lines. And then once you have inline signing, you can then use RNDC. RNDC is a remote named controller. We have been so far using systemctl to restart services. Generally, the practice is to use RNDC because you don't want to stop a service, especially if it is in production. because for bigger zones, it also takes time to load all of that up, and it will affect the service. So RNDC is generally what we use to do reconfiguration, reload of certain zones or domains, checking statuses, generating statistics, etc. So if you're doing inline signing, you can easily just use RNDC to also do signing and to load the keys in before you do that signing. One note here is that, again, this is client specific. There is now a new DNSSEC policy configuration option for 9.16 and up. And so I believe the idea is to kind of like replace the use of auto DNSSEC and inline signing with a DNSSEC policy configuration, which I think is something being done more with either not DNS and Power DNS. So same thing if you're doing NSEC 3, some minor changes when you're doing the signing. You'll have to specify NSEC 3 parameters there. Provide some salt that will be used to then sign. And it will not generate a DS record. I mean, because when you do signing, manual signing, you have a new signed zone file. You also have a file that contains the DS record. Yeah, like something dash DS set, your zone name dash DS set. That's usually the file name. And it contains two lines, two DS records that you will then forward to your parent zone. Parent zone will add it into their zone file and then sign the entire zone. Now, if you're doing inline signing like this, it doesn't automatically generate you with that file. So just a way for you to generate that is to use this command, DNSSEC DS from key, and then save that into a file, and then specify for which zone. DS record is just your public key, right? It's kind of like compressed version, hash version of your public key. So it should be easy to generate that. So this tool or this utility really does just does that. Okay. Now, for manual signing, another thing that needs to be changed is to point to the new zone file that has all the signatures. So you now update it to the signed zone file instead of the old one. Same thing here for the reverse DNS. And once all of that is done, you should be able to then do a query. Dig at your localhost for the zone that has been signed, and then plus DNSSEC. It should give you information similar to all the dig queries that we have so far done. So I only posted a few here for this domain. Okay, you've seen these examples already a few times today. And then here is for reverse DNS. You use a -X for a reverse query if you're providing the IP address. Or if you don't want to add a -X, you specify the FQDN of the reverse DNS entry. All right. So how do you now add those records, those DS records to the parent zone so you have that chain of trust? We mentioned a few new resource records that addresses this, right? But for quite some time, and still quite a number of folks do it manually like this. So you go into your parent zone. Usually they will have a form, online form, like for members or for subscribers, and then you can fill in the details. Once you've submitted that, they will usually have a script that will pull that information, and every, usually depends on their SLA, maybe every hour, they would add that record into their zone file and sign it. So as an example, like here we have pushing DS records for forward zone for one of the hosting provider. Okay, so you have to provide all the fields, the key tags, the algorithm, the digest type, etc. For reverse DNS, for reverse zones, if you all have IP address blocks, so we are a APNIC, of course, so we hopefully encourage people to sign the reverse DNS. So to add the DS record for your reverse zones, there is a DS-R data field that you can update. So within the whois update in the my APNIC, or what we now call as the resource database, I believe, you essentially can still do that there. Just add a DSR data field and then copy the pretty much the line for the DS record into this file. And I think that's mostly it. We have a few tools that you can use. Maybe we'll show you this. There's also a link in the wiki for this. Very useful utility. I tend to use this quite often. This is for visualization, DNSSEC, which we've talked about chain of trust quite a bit. So if that topic, if that concept is still not solid or, very clear to you, I think a visualization tool like this will help. And I tend to use that for troubleshooting. So usually if we generate new keys, if we're just doing signing, doing a key rollover, it's good to see whether you still have that chain. It's usually one line, like vertically. I just like move it like that so it's easy for us to see in the presentation. But you see there, the first one is dot, which is the root, okay? The corresponding public key, DNS key, and the corresponding DS key. Remember, the DS record for the child is added to the parent. So that's that there, which points to the DNS key of the child, because DS record is the hash of the DNS key, right? So the next part is the DNS key and the DS record for the next level, .NET. Same thing, okay? It signs the DS record of the child zone, which in this case is APNIC.net, right? So, and then within APNIC.net, we have different algorithms. I have 3 DNS key records, all using algorithm 8. I think I took this screenshot quite a while. I believe we're now using algorithm 13. But notice, one of that is using 2048 bits, which I would say will be the KSK. And then you have 2 that is using algorithm 8, but 1024 bits. I'd say that would be the old and new ZSK. Okay. Key rollover, in key rollover, usually you have overlaps when both of the keys are valid so that it doesn't disrupt with the validation. So, yeah. So if you're already doing DNSSEC validation, please use this tool. Really very, very useful to have this. Questions? I think that's the, yep, just a couple more slides here, different ways to deploy DNSSEC, which I think to some extent is still very, very much valid. The reason is because like for some time now, like we either tend to use whatever application we have, see whether it has DNSSEC features. And for quite some time, they don't have the complete features. Nowadays, most of these DNS application will have, really good support for DNSSEC. So generally, we would just rely on those. In earlier days, it's more common to use third parties. It's like what we call as like DNSSEC in a box that will sit in the middle of usually your pattern will be you have your primary server and then your secondary, right? So between the primary and secondary, you usually have a signer that sits in the middle. That can be your external appliance or Open DNSSEC is actually one of the things that is, it's a bit in the middle because it's not like a third party appliance that you would buy. You also like maintain it yourselves, but generally something that would be set up separately, sit in the middle of your primary and your secondary, do that signing for you, and you would rely on either an HSM or a software HSM because OpenDNSSEC supports that, and then you store all your keys into it. So that's still quite typical. It's very common. I think for us, we've used kind of like an external appliance for quite some time, but have now since moved into just relying on one DNS software. The format or the topology will still be you have the signer in the middle, but relying on available DNS applications to do that function for us instead of third-party signers. So that's it. That's DNSSEC zone signing. I hope you got some good information and background and the process on how to do DNSSEC signing. What we can do now is maybe go back into the labs. Yes.
I do all this while the because I have we have a DNS which is not DNSSEC yet. So can I do a DNSSEC on the in parallel with the existing one? Because we have now I have now a DNS without the DNSSEC.
Yes.
So I want to install DNSSEC. I cannot. Can I do this one while will not interrupt the current DNS operations? Do you understand my question?
Yes, I understand your question. I think you want to be able to provide the service like DNS service, but also sign it, which I think.
No. I have my current operational now. I have DNS.
Yes.
Now I want to do DNSSEC. Can I do it on the existing one, or have I do it on the separate machine?
It will be on the same machine. It
On
will
the
be
same
on the
machine.
same
It will
server.
not disrupt the operation.
If you're doing validation, it's I think as we have looked at, it's a simple line. If you do it right, it will not disrupt anything.
Yeah, that's why I'm asking.
For DNSSEC signing, what I would tend to do is do a subdomain first, create a different zone for that subdomain. So you're only enabling DNSSEC signing for that subdomain. And then do your experiments there. So it doesn't stop, say, for the university.
So if everything going well, for the subdomain
Yes.
to the main domain.
Because like the zone, remember the zone statements, you enable signing per zone. So if you're doing auto DNSSEC, you add those two lines under the zone statement. It's not a overarching config to add into the option statement that will apply to all your zones. It's usually per zone. So in that case, you can actually, to avoid disruption of the rest when you're still testing, maybe you're coming up with a process for yourselves and not sure if you missed anything, the best way is either to do it on a test environment, or if you want to do it in production to see whether it works, the safest way is to apply it on a subdomain. That's what I would tend to use. Actually, I would tend to set up a test environment first, but yeah, that's the second option.
Test environment with the exact.
It would be a different zone, different domain. Zone. Yes.
So after that, after it's successful, I just.
So if it's a different server, you'll do kind of like a delegation. It can still be a subdomain. Do a subdelegation for that subdomain to that authoritative DNS, and you do everything on that DNS server. I can help you if you want. Thanks for that. A really good question. I think, yeah, it's very common for folks to have those questions in mind before starting and before planning. Any other questions? Everyone still following us? Okay. Okay, I'll pass it on to Awal to go through the DNSSEC zone signing lab exercise and maybe just do a demo with us. So you can follow along if you have a lab assigned to you, and follow the same commands and the lab instructions.
Okay. So yeah. So this is the second session's lab. You see the wiki page have this forward DNS. This is the lab we are gonna follow now, and though we are gonna practice the DNSSEC configuration, but it requires you to set up the DNS first. For the authoritative zone, you need to have the records at least to sign. So we are gonna start from there. I'm on group 30, and you see that we have our default configurations there. I'm just gonna make sure that I have my options file with the proper configuration. I have the auto. I'm gonna change it to yes, but before that, let's see what the instruction says. So on step 2, in step 2, we are gonna disable the default hints file and gonna create a local fake root. We have already a local root here. By default, when you install the bind, it has the global root hints file there. So we are gonna change it by creating a different file called lab.root, and it will be in the default zone because it's there already. So let's see. So in the default zone, so named.conf .default minus zone, that's the file. And if I try to edit that, you see we already have dot zone here. So this dot means this is the root zone. And to reach to the root, we have a preview kind of zone within the resolver. So because we would like to test it locally, we have to change our recursive resolvers root pointers or root hints file to a local one. So I'm gonna change that. Let's first copy this. This double slash, it's gonna kind of deactivate these lines. We ignore this configuration, and I'm gonna put some new lines here. The file I'm gonna create is the lab.root. Saving this. Now we have this db.root, which actually has this database for all the root server IP addresses and records. This is the file. You see from A to M, all the root servers. We are gonna configure one. As you see here for our root zone. I'm just copying this. And since there is no lab.root, I'm gonna create that. Okay, now we have the format.
broken. Just using a tag to look it, give it a good look. So it says that to reach the root, go to x.rootservers.net, and the IP address for this one is our local labs root, right? Yep. Now need to give ownership of that file to bind. For that, I'm just using using the -r to change the ownership of all the files within the bind directory for the user. Yeah. So now if you see, even this newly created lab.root is user and the group is bind. Now since I'm gonna do the check from this local machine, so let's change the DNS resolver configuration that is in the net plan for its own IP address or loopback IP address, which is 127.0.0.1. So let's edit this file. And we are just gonna add here in the address section, we're just gonna add its own IP address, so that it tries to look for its own resolver when it would like to run some deep command or do some resolution. Now we would like to create zones, and it's better that we create a new directory called zones and keep our zone files there. Easy for us to do the lab. So let's make a directory called zone. So this sudo mkdir. So it's gonna mkdir is gonna create this directory named zones. You see we have now a zone here, but this is under the with the user root, and we need to change it. We'll do it in a little bit. Now within this zone directory, let's create a zone. Let's create zone file, and with the name db dot our group name. So let's do this. Db dot, for my case it's group 30 .com or .net, whatever. Yeah. In this lab setup, we have .com or and .net both for the lab. Let's create db.group30. So I'm taking group 30 for my zone name. For your case, you probably have your own group number. Just use that. And let's copy this. I copy that. That's gonna break the format. For formatting, probably need to text edit. Yeah, so this is gonna break my whole good one for this lab. So I'm just gonna show them quickly this also. So this is for my group 30. And so for the SOA or startup authority, you need to mention the domain name. I mean the name servers name FQDN, and then we have this email format without the @ sign. I'm just using it. I'm doing pretty quick without explaining much detail of each of the individual sections here. So we have the serial number. Remember, Shane said that whenever you change some information in the zone file, please update the serial numbers. And all these refresh and retry and expiry, these are related to your primary and secondary name servers synchronization, and the negative TTL is at the last part of the SOA record. We are having a couple of examples record RR or resource record configuration here in this lab. Wow, it's not taking so long. Yeah, maybe I'll create it a little bit shorter than what we have. This for the NS records and the group number. Please replace the access with your group number. Otherwise, this is not gonna work. I'm gonna give one example here with this www. Okay, what else? We need to create a zone and put the file of this this recently created zone file there. So I'm gonna use the local one. Get out of here. You see the local, for the local zones, we have a pre-configured file here. I'm just using that one for our group30.net domain. This is master. The file is gonna be pd.group30.net. Let's change the ownership for the files here in the zone directory. And now let's so that check conf. Remember we have some tools. MD check conf checks the configuration file whether there is any syntax error or not, and if without any output, that means it's okay. I'm gonna check the zone file configuration, which is for my group30.net, and I some IO error, which is okay. Yeah, I think this is not a problem. IO errors. Let's see if we have. Yeah. So if I just query for my own group, let's say big host or www.group30.net should give me some answer. Yes, I have this a record which I can get. And now I'm not going to configure the secondary or the allow transfer. This is for the secondary address configuration. Now with this, I'm going to move ahead with the signing and or configuring the forward DNS with the DNSSEC. So for that, I have to create some keys. Um, let's create a new directory with this mkdir and with the name keys, and let's go to the direct keys. Here we don't have anything at this moment. I'm just going to use the DNSSEC keygen tool to generate keys for my zone group 30.net with a bit size of 2048 or 2048 and with the algorithm RSA256. So as you can see in the command, this is by default gonna create keys which is called the zone signing key or ZSK. But if you'd like to create the KSK, which is in the second line, you have to use the flag KSK specifically so that these keys are for the key signing key. So first let's create the GSK and edit the group name with your group name. In my case, it's a group 30.net. And you see that I have a key created and it's a pair. So the common, so if you see what are the files? So one is dot key, the other one is dot private. Private is the private key and dot key is the public key. And you can see, you can read the contents here. So we'll read the contents later once we finish the KSK as well. So let me configure the KSK with the, you see, all the parameters are same. I'm gonna just add the flag for KSK. This also creates. So if you see now, I have two key pairs. And let's read the keys one by one. So this is the first one that I'm reading, which is 17610, and it says it's a zone signing key or ZSK. And remember, for the second one, I have the 44356. I use the minus F KSK. That means this one is gonna be my KSK or key signing key, and you can see the key signing key. So now we need to change the ownership for these keys so that bind have ownership for this, because at this moment it has the root as the owner. So we change it. Now let's create a DS and delegation signer. Remember, is it's kind of building the relation between the parent and the child in terms of the secure entry point or SEP. So let's create that quickly here. And so what I'm doing is I'm using the DNSSEC DS from key, this tool. It is gonna take my, so it's gonna take my public, the KSK. So I have to put my KSK here, which is this one. This is my KSK, because DS is the kind of the can I say digital signature or kind of the shortest version. What's the name? Hash of the KSK, and I'm gonna put it to my parent's zone file. So there is a relationship or chain of trust built between the parent and the child. So this is my public, this is my KSK, and the public part, which is the key, and I'm gonna keep it to some file, just naming it as group 30.ds, something like this, ds key. So yeah. Yeah. Let me see if I can. Yeah, so I'll just manually add these to my parent zone. Oh, not yet. Yeah. See, we have the zones. We have this .NET zone where I'd like to. So this is the db.net. So I'm gonna it's a net DSSEC is the file which is included, so I can just put my information there. I'll just copy and paste here. So back to the instructions. So I have my DS set, DS records added to the parent, and I have to change my zones configuration to add the DNSSEC related commands or instructions here. As you can see, the key directories are added, and also the auto DNSSEC is set to be maintained. So you keep on checking the keys and maintaining the and updating it when the expiry comes. It updates that, and inline signing is actually keeping your main DNS configuration or zone file configuration as it is, and supply the records from the signed file. So I'm just gonna edit that from the zones file that I have. Oh no, it's not. It's amd.on.local. Let me add those information here. Just yeah, you don't need to do this and all the decoration and stuff. Looks good. Yeah. So this is it, and I'm just using the RNDC tool to so let's see if my bind is still running or I am having some error. It's running, all zones are okay. So let's see. Let's do some dig for my own records. Yeah. Yeah, I think I get the answer with the signatures. So this is my, previously I queried, it only gave my A record, but this time it is giving my RRSig as well. And you see the DO flag is set because I requested DNSSEC information. And what do I have? Since we have the main, so yeah, we have to change it to yes as well. So let me change that. Options. Let's go and change the DNSSEC validation to okay, so I have from last time. Yeah, but anyway, I have my answer with the signatures, and that's probably it for today. We should have covered more, but
Okay,
yeah,
I hope
anyway,
you're
yeah,
all able to follow
I
the
did it very
DNS.
quickly.
Yeah, it's pretty quickly done because we are also running out of
Running over.
time. Thank you, ThaiNOG, for allowing us to extend for at least, I think, more than 15 minutes. But I hope you guys manage to follow along with the lab. We can make that available for the next few days. So if you are keen to try it along and try it on your own time, please feel free to do so. The lab will be available until the end of the week. During this conference. So if you have further questions about this, please let us know. You know how to reach both Awal and myself. Unfortunately, we didn't have time to cover DNSSEC, I think the last part, which is key management and rollover. And we didn't touch on reverse DNS as well. The process for reverse DNS is pretty much the same, but the key important part as well is not just signing, as I've mentioned, I think a few times, and also Awal has done, is the key management and rollover. So we have a section for that. We have the slides available. So I hope you take the opportunity to go through the materials and a plan. You need to have like a plan on what applications, what algorithms you will be supporting, what is your plan for rollover, how often you're going to do that. And I would encourage you to look at some of the providers would post or publish what we call as a practice statement. APNIC has that as well. You can find it on the APNIC website. And we follow that as a kind of like as a guideline when we are signing our reverse zones. So similarly for a lot of other providers, particularly for forward DNS, they would have something similar as well, and would be good for you to also do the same. So you have that guideline when you're implementing DNSSEC and also doing key rollover. So I think that's all the time that we have. Thank you very much for joining us and for participating. Um, Thank you to ThaiNOG team for allowing us to do this session for you. Thank you.
ขอเสียงปรบมือให้เชนนะครับ Thank you very much, Chen. Yeah. So before leaving, I would like to invite Kun Patama to give the token of appreciation first. Okay. Thank you very much. Next, wow. Okay. Okay, thank you very much, our instructor again. So as Shane mentioned, APNIC will also have the post workshop on 25 to 26, the next 3 days. So if the ThaiNOG community interesting to join the workshop, please feel free to register. We have we also have the free ticket that APNIC also give to the community. So please please reach us in any communication channel, in line, in email, or whatever. So please feel free to ask us. So, and for all we know, I would like to thank you every for all both online and on-site participants for your attention and your to be here on our event, since this event is one of our first in-person meeting. So, and I hope that next year we will meet again soon. Thank you very much again, and ขอบคุณทุกคนที่มาร่วมงานนะครับ so see you next time, see you next year. Thank you very much. Bye bye ครับ